Okay, ladies and gentlemen, so in the previous video we talked about different ways that we can introduce samples on the infrared. So the IR spectrometer we said can handle solids. You just have to put them into a slurry called Nujol or compress them into a salt disk. We can also have liquids. Those are probably the most traditional type of sample that's analyzed in the infrared, and you put them directly on a salt crystal, and a couple of drops is all that you need. And we can also analyze gases. We just need a specialized gas chamber so that way the gas cannot escape inside of the sample compartment, and we can seal it off and analyze the infrared just like before. But in the previous videos, I told you that there is another method that we can use if we have some extra money to spend on an IR instrument. And this is called the ATR attachment. The ATR stands for Attenuated Total Reflectance. So you've got to keep in mind that this is an attachment. Imagine you going to the car lot and purchasing a vehicle, and the car salesman says, well, do you want the standard or do you want the luxury version with the leather seats and the backup camera? Okay, well, this ATR is the luxury version of a vehicle, or in this case, an infrared spectrometer. So the ATR makes your job much easier when it concerns analyzing samples. But it is an attachment, it has to be purchased separately, and it has to be added on to the instrument that you already have. Our ATE or ATR instrument was about $18,000. It was almost as much as the instrument itself. So that gives you an idea of how much money can be invested into an ATR attachment. However, again, it makes your job much easier when it concerns the analysis of an organic compound. All right, so for the ATR, or attenuated total reflectance, what happens with this attachment is that normally, I'm going to put normally here, your infrared will go through and it will scan one wave number at a time. 4,399, 3,998, 3,997, and it goes all the way down to 600. And this takes some time. We're going to say a couple of minutes here. And within a couple of minutes, you get one infrared spectra, and that's it. That's all you get. If you want to run another one, just to kind of double check yourself to make sure that that is the proper infrared, then you're going to have to wait another couple of minutes. If you want to do a third analysis, again to double check yourself to make sure everything stays consistent, it's going to be another couple of minutes. And this is just really the process of running. This does not include the process of loading a sample up. With an ATR attachment and with what we call an FTIR, your analysis can be basically shortened to a couple of minutes to a couple of seconds. It's actually so quick that this combination can easily produce an infrared spectrum in such short amount of time that by default it does around 45 scans, and it averages all of those 45 scans together to give you one infrared in total. My job is much easier as an analyst. Not only that, but I'm getting multiple infrared scans, each one taking a matter of seconds, and the machine is averaging those together and giving me a spectrum on the computer screen. Well, the ATR attachment, we know what that stands for, attenuated total reflectance. And the FT in FTIR really allows this process to speed up much quicker because the F stands for Fourier and the T stands for transfer. Fourier transfer. The FTIR allows the instrument to bombard the sample with all wave numbers at one time. It basically opens up the floodgates and allows all of it to go through. And the way that the FTIR is made is that it looks at all of these different movements and workout routines that's going on in the molecule at one time, and it produces a spectrum all at one time. It doesn't have to go through one wavelength after another in order to do its job. Okay, so here is a picture of our infrared spectrometer. This is the normal infrared from Shimatsu that we have in our laboratory at this time. And this is the major workhorse. This is the one that we go to most often because it's the most current and the most relevant that we have at least. All right, well, traditionally what would happen is that this lid would open up and then I would put a salt crystal down into the infrared and then I would close the lid back and I would scan the sample and produce an infrared spectrum. Just like before, there's no difference, right? I can still use salt crystals in this thing. Nothing special about it. That's the way that all the infrareds are made. So the process of analyzing the samples are the same. However, this infrared spectrometer can come with an FTIR attachment. And the FTIR attachments will all look a little bit different, but it's like a TV. They have very similar features on them. So if you look at the top piece on this instrument here, you see almost like a huge, what I'm going to call anchor that points downward at the sample platform. That is almost the traditional ATE attachment look. All right, here's another one. This is inside of a Perkin-Elmer infrared, not a Shimatsu, but it's the same kind of concept. You've got this anchor that kind of points down at the platform that you put your sample on, and then there's kind of a box in here that holds the whole thing up and makes it suitable inside of the machine. And then finally, here is a picture of a Shimatsu version. It might not look exactly like the one that we have, but it's very similar. Again, you see the anchor that kind of points down. You see a platform that you would put your sample on, and this whole thing gets sandwiched inside of the sample compartment. That piece, that anchor that you're seeing in these pictures, it's the anchor that we're talking about. That's 18,000 bucks, if not more, depending on what you have. Now, the reason that it's so expensive is because the way that this thing works is you have a platform and there's a small hole in the platform, and that small hole has a crystal that is made into that metal platform. And that crystal is basically a diamond. And as you know, diamonds are a girl's best friend, and it's a lot of money at the same time. So we're really paying for the diamond that we are using in the ATR. Now, the reason that the diamond is really probably preferred over all of the other types of crystals that they can put in here is that a diamond is very hard. It's one of the hardest substances known, and it's very hard to damage the diamond. So this thing's life expectancy is going to be years and years and years as long as you're handling it the proper way. And because of that, you do not have to buy infrared cards. You do not have to buy salt crystals. You don't have to buy any kind of specialized compartment cell or chamber for the solids or the liquids that you're using. And this thing can do the job of all of those, and you don't have to worry about it. It's also very easy to use because what would happen is that if I have a liquid, I would put a drop or two of liquid over this crystal, just make sure that there's enough there to cover it, and then I hit scan on the machine. That's all I have to do. There's no salt crystals that are needed in the ATR attachment. That's the whole beauty of using it. I don't have to smear anything on a salt crystal, make a sandwich of it, put it in a metal plate, put it into the machine, clean them off before and after. I don't have to do any of that. I put 1 or 2 drops of sample directly on the plate and I hit run. That's it. That's why this thing is so convenient. If I had a solid, the solid would be very similar. If I had a solid that would go onto the salt or onto the plate of the ATR attachment, I would just put a few crystals, enough to cover up that diamond, and then I hit scan. There's no new gel involved. There's no mineral oil. There's no slurry that I have to make. That's it, people. A couple of drops of liquid, I hit run. A couple of crystals on the plate, I hit run. That's all that I need to do. And that is the power of the ATR attachment. Now, there's one drawback that we need to talk about. And that drawback is what if I put a sample, a liquid sample, on the crystal, but that liquid sample loves to evaporate? It's very volatile. Well, that's the purpose of the anchor. So traditionally in an ATR attachment, you would see a box and this would have a stem that comes up and over and an anchor kind of points down onto the box itself. So let's say that here is that plate with the diamond. I would put a few drops of my liquid onto that plate and I put a cap over top of that liquid. That cap is traditionally a piece of plastic in a way that does not degrade in the presence of an organic compound. So the cap puts a hood over the actual ATR attachment and it prevents all of my sample from evaporating from the face of the plate because it is an open air. And what would happen is that if I wanted to, I can take this lever and I can crank it down, and this lowers the anchor down onto the plate, and it prevents that from escaping underneath. So in other words, it makes a very tight seal. So it puts a little bit of pressure onto the top of the cap, and it holds it down onto the plate so that sample cannot go anywhere. Some people also suggest you use this anchor for a solid, and they prefer you to put a couple of crystals on top of the diamond. They know that some of the crystals are very fluffy, and some of the crystals can be blown away with the air currents that are in the room. So sometimes you'll see them put some solid crystal here at the bottom. They'll put the same cap on top and they will lower the anchor down and put pressure on that cap so that the solid cannot go anywhere. So the reason that I would use the anchor and lower it onto my sample, number one, is if I have a very volatile substance. Almost every time that is required. It prevents the sample from evaporating off of the diamond itself and into the room. And number two, it's not a have to, but some people prefer it, is that if you use a solid, then you would lower the anchor down onto the solid with or without that cap on it, and this prevents it from basically blowing away. Kind of the similar concept of a liquid, but it's just a solid instead. So that is what we call the ATR attachment. Some people will use an ATR in their laboratory, other people will not because of the cost that's associated with the attachment itself. We do have an ATR attachment in our laboratory, and that's traditionally what we use very often because we paid enough for it, we might as well get as much use as we can out of it. So the ATR attachment is in our laboratory. We do use it, and we use it quite often. But like everything else, we start you off on the older machines. You have to run those salt crystals because that's kind of still done in a laboratory, and you have to get comfortable with that process. And then we'll upgrade you to the ATR and allow you to use that attachment in an infrared spectrometer. Okay, so that's it of the sample chamber. We get to move on now. So solids, liquids, and gases are okay to run on salt crystals or in specialized chambers for the gases. And then I also have an attachment called an ATR that allows my job of sample prep and sample analysis to go much quicker. Again, if you want to know more about it, you can simply go to Shimatsu's webpage. And when you go to Shimatsu's webpage and you go under their products like we did before, and you go under molecular spectroscopy and click infrared, you're going to see different infrared instruments that they have available to you. And here at the very bottom, you're going to see the fundamentals of FTIR, and you're also going to see a link down below for the ATR attachment as well. So that's up to you. If you want to click these links and read more about the equipment and more about the instrument and kind of get a good feel of what's going on, then by all means, there you are. One of the links, you can't really see it completely on your screen here, but one of the links is called ATR Precautions. And this goes through the whole concept of don't please don't rely on ATR to never mess up because it does. And there's certain things that it can run a little bit better than others, and there's a proper way to handle the ATR attachment. And some people get carried away. So this document is just a very quick summary. I think it's more than what we need for this course, but to tell you that there are problems with ATR. We get some shifts, we get some samples that it can't quite run as good as a salt crystal, but overall it is a much better method to utilize than the crystal itself. Okay, so in the next video we'll move on with other pieces and parts, and after that we're almost done with the lecture.